Welcome students. So today we have a numerical regarding star and delta. So the question is like that. So the question is given us like this. So there is a circuit is having the resistors are connected like this, and we need to find out the equivalent resistance where each resistance value in the circuit is given as 1. So you can see the circuit. So this is the terminal A, this is the terminal B. We need to find out what is RAB. What is RAB? Where each resistance value is 1. Okay, so when you are giving this type of circuit, first you need to find out in which way we can solve this. So one can easily guess that this is basically a star delta conversion problem or delta star conversion problem. So you can find here you can see that there is one delta, the second delta, third delta or fourth delta. So either you can convert star to delta or delta to star. So now here I am giving hints to convert this circuit from delta to star. Okay, so the circuit is like that. So when we will approach to this type of numerical, so first we will have to check, or we have to check in this way. So we have to look from the terminal A and B. So when we look from the terminal A and B, you can see here these are this resistance 1 and this resistance 1 are in series. So by adding this we can get the resistance value equal to 2, which is with the parallel with 1. So we will approach this circuit step by step manner. So we will redraw the circuit again. So I am redrawing the circuit again. So all the resistance values are kept as it is. So only I am changing this 1 and 2 which are in series. So I make it as 2. So now this 1 and 1 becomes 2. So all the values I kept as it is. So all the values are 1. Okay. So now the question is that this 2 and this 1. So you can see here these 2 and 1 are in parallel. These 2 and 1 are in parallel. So we can make it parallel and we can find out its equivalent resistance here. And now the question is that in out of these 3 deltas, where I can put where you can convert delta to star. So this will come in practice. So basically you can convert this delta to star. So I am making like this. So this delta, so I can rename this is your terminal C. This is the node C. This is the node D. This is the node E. So in this node C, D, E, let this is your R1. This is your R2. This is your R3. So I can find out R1 and R2 or R3 as the resistance between CD or CE and DE are equal. So I can find out R1 or equal to R2 equal to R3 equal to 1 by 3, or I can write down 0.333. Okay. So in the next circuit, so I can make it parallel this 2 and 1, and this delta we are dividing into its corresponding star. So let us draw the next diagram. So by drawing its next diagram, I will get this type of curve. Okay. So I can get this type of curve. And we kept this is your 1, and here you can see in this previous circuit. So between D, so this 2 and this is I am naming this node as also I am naming this node as F. So in between D and F, this 2 and 1 are in parallel. So I can write down 2D in between. So this is the node D and this is the node F. So I can write down like this. So this is your basically 1 parallel with 2. So the value is 2 by 3. So you can write down 0.666. So by rewriting this, I can get this is the node. This is the node A. This is the terminal B. So this is 1. This is 1. So by converting it into star to delta, I will get this is 0.333. This is also 0.33. This is also 0.33, and this is I am getting 0.666, and this is 1. This is also 1. Now it is very clear that this 1 and this 0.33 are in series, and this 0.33 and this 0.66 are in series. So if we redraw it, so you can redraw the circuit like this. So by redrawing the circuit, so this 1 and 0.33 are in series. So I can write down this is your 1.33 and this 1 will as it is. So in between them this 0.33 will come. Then the 0.666 and 0.33 we can add and it will make as 1, and here also this 1 resistance will be as it is. So this is your terminal F, where this is the node A and this is the node B. Okay. So now we can see that either we can take this is 1. So this is you can take as 1 delta, or we can take this is as 2 delta. So either you can break as delta to star. So to get its simplified form of the circuit. So now I will break this second delta. So by breaking this second delta, so I can break like this, or I can. So you can see here this node is nothing but this node. Both nodes are equal. So I can write like this. I can redraw the circuit again. So by redrawing the circuit, I will get like this. You can see here this is your 1, this is 1. So already I wrote this is 1.33, this is 1, this is 0.33, this is 1, and this is 1. So now I will break this delta to star. So I will take this is your, I will break like this. Let this is your resistance small a, this is resistance small b, and this is resistance small c. So by using this formula, I can find out A equal to 1 into 1.33 divided by the total resistance across delta, the branches of delta. Similarly, B I can find out by multiplying 1 into 0.33 divided by, so all the equal resistance, and C we can find out by multiplying 1.33 into 0.33 divided by 1 plus 1.33 plus 0.33. So here I can get 1.33 divided by 2.66. I can get 0.33 divided by 2.66. Here I can find out 1.33 multiplied by. So remember, when you solve this type of numerical, always use your calculator. So I will get 0. See here I will get 0.438 divided by 2.66. So by solving this thing, I will get 1.33 divided by 2.66. I will get around 0.5 will come around 0.50. So again I will get like 0.33 divided by 2.66. I will get 0.124, 0.124, and here I will get 0.165. I will get 0.165. Now I have to again redraw the circuit. So I will redraw the circuit like this. So this is your A. Now this is your B. This is your C. So previously 1 is there, and this side also 1 is there. Okay, so I can put this value of A, B, C correspondingly. So I can put A equal to 0.55, 0.50 here. So A equal to 0.50, B equal to 0.124, C equal to 0.165. Now in this circuit you can see here these two are in series and these two are in series. So I can get a circuit like this. So finally this is your A, this is your B. So I can get a circuit like this. So if I redraw again, so I will get a circuit like this. So this is your 1 and this is 0.50, both are in series. So I can find out this is 1.5. So now these are series parallel to each other. So here I can write down this is 1.165, this is 1.124, and this is 1. Okay, so this is your A, this is your B, and here I can find out RAB equal to 1.5 plus 1. So here 1.24 parallel with 1.6165. So I will put the formula. I am putting the formula directly. So now you know the method how to solve it. So finally you tell me what is the value. So approximately I can get 1.24, 1.165, 2.3, you get around 3.06. So the RAB value equal to 3.06. So now you got the method, or you can apply any other method that you can divide any other delta to star or any star to delta to find out the answer. But remember, the answer will always be same.